Hey guys, today we're going to finish up our last section. It is 11.9a. We are solving radical equations. If you'd like to follow along while I do these examples in your textbook, I am on page 822. So our first examples that we're going to solve today are we are going to have just a single radical. That's this guy right here, radical symbol, or square root if you want to call it, and we are just solving from there. So something to remember as we are doing radicals is that if I have the square root symbol, the opposite of the square root symbol is taking something and to actually square it. So if I had an x down here, squaring it would be raising it to that second power. Okay, now remember we do that because this is a radical symbol, and since there's no number here, this is like saying we are taking the square root of something. So the opposite of square rooting something is to square it. So keeping that big idea as we go through today, let's do some examples. The first one is the square root of x, and it equals 8. So I want to get rid of this square root, so I am going to square it. And what you do to one side, you must do to the other, so I'm going to square it. This square root and this square cancel each other out. I'm left with x. And on my other side, we have 8 squared, 64. There's my answer. All right, on our next one, we have 6 equals the square root of 4x. So again, we need to get rid of this square root symbol that we have right here. So the opposite of taking the square root of something is to square it. I'm going to square it. That gives me 36 is equal to my square root and my square cancel each other out. That gives me 4x. Now I need to finish solving that. So if you need to get your x by yourself, you need to divide both sides by 4. Divide by 4, divide by 4, and in this case, x equals 9. One more that's like this just to be sure. We have the square root of 3x is equal to 1. Now again, the opposite of the square root is to square something. I'll do that to both sides. These cancel out and I'm left with 3x is equal to 1. Now again, we want that x by itself, so we're going to divide both sides by 3. Now the reason I bring up this example is you are allowed to get fractions. That does not mean you are wrong. So this answer is 1/3. Okay. Now in all of your work, this homework assignment, you can check your answers. So if I were to go back to this first one and check, I would take this solution that I got of 64 and plug it in. Is the square root of 64 8? Well, yes, it is. So that one checks. If I take my answer of 9 and I plug it in here, we would have the square root of 4 times 9. Okay, well, that's 36. Is the square root of 36 6? Yes, it is. And on our last one to check, we'd have, taking our 1/3, is the square root of 3 times 1/3. Okay, well, 3 times 1/3 is 1. The square root of 1 is 1. So all of my work checks. Let's move on and try some more examples. All right, now in these examples, my only concern is, especially on this first one, is I have something new that's right here. So my square root piece is not by itself, which is what I want. So I want to move this plus 3. So I'm going to go minus 3, minus 3. That's going to give me the square root of x is equal to 7. Now I'm at the same situation I was on the last slide. So I need to get rid of the square root. So I'm going to square, I'm going to square, and I'm going to get x equals 49. Again, if I want to check, I can put 49 in there. The square root of 49 is 7. 7 plus 3 is 10. So yes, it checks. All right, let's do our next one. This one, we already have our square root piece by itself. And again, we want to get rid of the square root. So squared, squared. Now this time I have 2 things left underneath, x minus 5. 4 squared is 16. All right, x is not quite by itself, so I'm going to go plus 5, and that gives me x equals 21. Again, if I want to double check myself, 21 minus 5. All right, well, 21 minus 5 is 16. The square root of 16 is 4. So yes, it checks. So far so good. All right, on our last one for this example, Again, we have this plus 4, something being added or subtracted outside of where our square root symbol is. So we are first going to minus 4, minus 4. That gives me the square root of 2x minus 1 equals 3. All right, again, square root we want to square to get rid of. So that means I am now left with 2x minus 1 equals 9. All right, some nice basic algebra to finish. Plus 1, we get 2x equals 10, divide by 2, divide by 2. Looks like I am getting x equals 5. All right, let's do that quick check if I put that 5 right there. We know that 2 times 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. 3 plus 4 is 7. We've gotten all 3 correct. All right, let's keep going. All right, this time I'm noticing I have a coefficient or a number out in front. That reads 3 times the square root of x. So if I want to get rid of that 3 first so that all I'm left with is the square root part, I am going to divide both sides by 3. Now I'm left with the square root of x is equal to 7. And now we're back to our basic ones. I need to get rid of that square root sign, so I'm going to square, x equals 49. All right, let's double check this if I put a 49 in there. The square root of 49 right here is 7. 3 times 7 does give me 21. It checks. All right, let's get to our next one. Now, on this one, the square root of x is being divided by 3. Okay, so if I want that square root of x by itself, that means I would have to multiply both sides by 3, because again, this guy on the top, the square root of x, was being divided by 3. So the opposite, let's multiply. Okay, that means these guys right here are gone. That's why you did it. And you are left with the square root of x is equal to 5 times 3, 15. All right, last step, we have the square root of x. We need to square. This gives me x equals, you may need to grab your calculator for this, 15 squared is 225. Okay, again, if we want to check this, we'd put 225 in there. So again, the square root of 225 is 15. 15 divided by 3 is 5. We're golden. All right, last 2 examples. Now, what you're noticing, I'm hoping on these ones, is that we have a square root on both sides, or at least there's 2 square roots to be had, okay? On this first example, it's nice because you have a square root here on the left and on the right. So we're going to start with the same step we've been using. I'm going to get rid of the square root by squaring, and I have to do it to the other side. Now, this square root and this squared, they're going to cancel each other out. Left with x plus 1. This square root and this squared, they're going to cancel each other out. And I'm left with 3. Basic algebra, minus 1, minus 1. We're getting x equals 2. All right, I'm going to check myself. This would be the square root of 2 plus 1 is supposed to equal the square root of 3. 2 plus 1 is 3. So is the square root of 3 the same as the square root of 3? Yeah. You can put them in your calculator and get the decimals, but we don't need to because both sides are identical. All right, let's try our last one. On here, we've got a square root minus a square root. Okay. Now, like on our first example, we want these guys to be on separate sides. So I'm actually going to go plus the square root of 3 plus the square root of 3. Sorry, 3x, I should say. So I am left with the square root of x plus 8 is equal to the square root of 3x. Now I'm back up here at this first step that we were on the other problem. So again, I want to get rid of the square roots. So I'm going to square. I'm going to square. This gives me, cancel, cancel, x plus 8 is equal to square root, squared, cancel, 3x. All right, minus x. This gives me 8 equals 2x. Divide both sides by 2. Looks like I am getting x equals 4. All right, we want to check this guy out since it's a new one. So again, I'm going to put the 4 here and here. So I would have 4 plus 8, that's all underneath my square root, minus 3 times 4 underneath my square root. So in this first one, I get the square root of 12 minus 3 times 4 is also the square root of 12. These two things are identical. So yeah, if we subtract them, they are going to end up at 0. So it checks. Homework for 11.9a. Okay, you are on page 826. You've got all odd questions, so please make sure you check your answers in the back of the book. And again, this is super important. You saw me show all my work because obviously there needs to be work to get these. Show all work because if there's no work, there is no credit.